Good afternoon, and welcome to what I am sure is going to be a very exciting discussion about robotics and the industrial metaverse. I'm gonna start with Sami Haddadin, and for those of you who don't know him, he's a serial entrepreneur who has started companies in Germany and the United States. He is, as was just mentioned, head of the Robotics and AI Institute at the Technical University of Munich, but he's also chairman of the Bavarian AI Council, which covers AI, quantum, and space, and has a budget of almost 3 billion euros. So let's start, Sami, by asking, how is AI being applied to robotics, and what can we expect beyond now?
Right. Yeah, so Jennifer, I think what is safe to say is that we see a lot of AI breakthroughs, not only over the last 10 years, but also right now. I mean, ChatGPT just kind of surfaced to the real world. People are using it and kind of playing around with it, and it seems that there is infinitely many possibilities to use that technology for the good and for many other purposes, obviously. But I think what is kind of interesting is that if you think about robotics, then it is not only application of AI to robots, but actually robotics as a field and the problem of building and designing and controlling these physical embodiments is the next stage, the next evolutionary stage of AI. So if you compare it to, for example, the data science problem of cancer detection and radiologic images, it's a classification problem, right? So it's like input data, output data, classification, and you support the human, the doctor, for the classification problem. In robotics, it's really about building intelligent agents, physical embodiments, that learn how to interact with the physical world, make sense of the sensory perception, process that, deduce actions, prediction, and really it's more about intelligent behavior and not just intelligent relations that you build. So these systems are really trying to solve almost holy grails of AI, meaning manipulation, locomotion, and interaction with the physical world. So they have to be aware of their own body, of the other entities in the world, and the environment.
So let me now turn to Quirin Görz, who is the CIO of KUKA Robotics, which is one of the predominant and most successful robotic companies in the world. So Quirin, what's your point of view on how AI is impacting robotics?
Yeah, thank you very much for the introduction. Yeah, I think in the future robotics will solve a big issue that we're facing today. In the future, I think robotics will safeguard prosperity of our society. So we're facing many challenges today. On the one hand side, we have labor shortages, we have supply chain issues, and many other challenges that I don't think I need to name today. So how can robots help to solve these issues and safeguard prosperity? For example, let's take this glass of water. So for us, this is a very simple task to grab a glass of water, actually. But when we look back, when we were kids, it took a very long time to learn how to handle such a glass securely, how to rotate it maybe without pouring all the water on the floor. So I have a 5-year-old daughter, so it even sometimes happens that there is some water on the floor. So the question is, how can we teach a robot how to handle such a glass of water? And I think the answer is AI. With AI, we can simulate different states of reality. So before we have been also already talking about the simulation to reality gap. And what we see now is with AI, we can simulate the physics and the motion of the glass, and we can also simulate the physics and the motion of the water inside the glass. And if we can transfer this knowledge now into a robot can start to handle a glass of water. This seems to be very simple, but it can be applied in different areas. So you can use it, for example, in care, you can use it in service robotics like restaurants, or you can use it also in laboratories. So there is immediately a huge range of new applications possible. So in the past, robots were always doing this repetitive tasks in automotive, spot welding, gluing, stuff like that. Very simple ones. And now with this, we have plenty of new opportunities how to apply robotics. Yeah?
Can we delve into some of those new opportunities? Sami, what does applying AI to robotics and introducing physics into the equation, what kind of opportunities does that open up?
Well, I mean, in a way you could argue what is most importantly to actually leverage the power of simulation and AI in robotics is that the simulated world renders the physical world to some extent. So that anything that you hypothesize in these simulations is roughly that the expected outcome is correct. So if you learn something in this physical world, in the simulated world, that it actually applies to the real world. And let's assume that we can do that, which is a very, very challenging task. And we call this the sim to real gap. And we need to close that sim to real gap, which means our perception in the real world can be fed into what we call digital twins or the Metaverse, used for prediction and then for the learning, and we can apply that. So if we can do that, and this has been done the last years for the first cases, then you can especially start to tackle the holy grail of robotics, which is manipulation, which means grasping the world, manipulating it, interacting with it, shaking hands, but also creating music, creating art. It's this kind of idea that manipulation as a process is fundamental to human intelligence, and it's also fundamental to robotic intelligence to be able to be useful in the real world. And if we can do that, and we see this over the last 5 years more and more, then we can do all the things that we have been dreaming of. Not only the fantastic things we've been seeing as in the industry, logistics, during the pandemics, we wouldn't have received all the goods if not all the logistics robots would have been operational. If you go to state-of-the-art ORs nowadays, robotic surgery has become the state-of-the-art. Millions of operations are being done with robots, yet without a sense of touch. And other things we are using in everyday environments are vacuum cleaners, lawn mowers, drones. All these are robots that have now reached our reality, right? So in a way, I think what is now the fundamental situation in which we find ourselves in is that from these isolated little helpers, we're now trying to integrate them more and more into more complex systems that can do more than just moving around, but now we can interact with the world, which would be opening up fantastic opportunities for healthcare, for service robotics. If you think about robots being the extension of humans, so it's more like an augmentation, it's our tools to explore Mars, space, underwater. So I think the fantastic opportunities we see nowadays with the convergence of communication technologies, 5G, 6G, maybe quantum communication, robotics and AI opens up perspectives to interact with robots in a way that they extend our capabilities beyond what we have seen so far. And in a way, I would argue that the other thing that can be used for us as humans really fundamentally is that networks of robots can serve us and acquire knowledge in an accelerated manner. One of the sessions before was about exponentiality.
Yes.
It's fundamental to the metaverse question and the question of can robots acquire knowledge and skills to manipulate the world is, can we make use of the collective of robots? So can they not only learn in the digital world, that is with the close sim-to-real gap, but also can we use these robots then to learn as a network and therefore acquire knowledge in an exponentially fast manner. So basically learn something in an instant. So for the ones who have seen Matrix, so when Neo learns karate in the digital world, so in the metaverse, and he knows karate, so that's kind of what we're looking for. Robots that can learn the things we want them to do in an instant, in a blink of an eye, to be useful and to be, for example, used in fundamental societal problems. So I think this is really one of the core goals we want to address. Robots for society, robots for the grand challenges of our society, and I think this synergy point at which we are at the moment with the transformative characters of AI, communication technology and robotics opens up fundamentally new tools for mankind.
So, Quirin, KUKA, focuses heavily on in industry. You work with industry. How do you see the industrial metaverse developing?
Well, from my point of view, the industrial metaverse will help us to to really create these networks, to really bring together different robots in a network. And there you can then apply different, let's say, engineering approaches such as simulation. So there we can start to simulate different real-world scenarios, combine this with the learnings from the real world, have this kind of feedback cycles, and combine really the knowledge from the network itself, and correlate it also with some learnings from the virtual world, and then bring it back into the real world. So I think this will really help to leverage these feedback cycles between real world and digital world. Because today, often the connection is missing, and we use different standards. For example, if we look at simulation and engineering tools, there are so many different engineering and simulation tools out there. So if you as a group of engineers want to collaborate, it's already quite difficult. But if you really want to have now robots from different vendors, different shapes, trying to collaborate, they need to follow some joint or common standards. And then you can start to connect them. And this will happen, from my point of view, in the industrial metaverse.
What kind of applications are you seeing or will we see?
So what we already see is, for example, all these mixed reality scenarios. It's not the real metaverse like the definition of Paul would see it, but it's maybe some kind of an entry point already, where you combine the virtual world with the physical world, and you can steer maybe a kind of a digital representation of the robot, and then steer with these movements also the movements of the robot, so that you kind of have only the virtual model in front of you, but you actually move a real robot behind you. So that's already possible. That's one of the first things, I think. The next thing is really bringing offline programming of robots into the real world. So that can be done already for specific tasks today, but we are not leveraging this network effect so far. So if you go for arc welding, spot welding, there are different applications that are very sophisticated. It took more than 15, 20 years to develop all these approaches, how to do this. And if you want to scale this and really want to have these exponential effects, then we need to find different ways. And I think there the metaverse will help.
I know that there won't be, you and I have discussed that there won't be just one metaverse. Already China is moving ahead, building its own metaverse. How important is it going to be, for companies to remain competitive, to, start taking advantage of the industrial metaverse?
So today I learned that in Bavaria we are already in a very comfortable situation, also with Sami and his institute. That's really impressive to see how much Bavaria is investing in this topic already. But if we really look at China or the US, and especially China, then we see that there's much more investments. There are many more companies now starting to go into the direction of robotics, of AI, and also the metaverse. And they have already some really big players in place, like Tencent with the gaming industry. So the metaverse will come out of the gaming industry. They are already at the forefront. So there they have some, let's say, kind of unfair advantages already. And therefore, I think my call for action for Europe is that we need to invest much more into these technologies, and also as companies, we need to take care that we don't fall behind, because you mentioned ChatGPT already. So ChatGPT, from my point of view, they will not replace a software developer, but a software developer that is able to use these kind of technologies in the future, and also other people knowing how to use a robot and AI in combination, and maybe also other technologies, they will start outperform all the others immediately. They will be much faster, much more productive. And they will then kill the jobs of other people. Not AI, not robots, not the metaverse, but people knowing how to do this. They will outperform their colleagues. The companies that have these people will outperform other companies. So that's going to happen from my point of view. And there we need to be careful, especially in Europe, that we don't fall behind, because we see lots of movements already in the US. You have a big player like Microsoft, Nvidia going into this direction. And on the other hand, you have China with Tencent, Baidu. They are also going into this direction. And we are somewhere in the middle, and we still struggle, from my point of view, so which direction should we take? And from my point of view, there's only one direction, straight ahead.
So, you know, what you're saying is people shouldn't worry so much about having their jobs taken away by robots, but rather by having their jobs taken away by people who know about robotics and AI. So we need to get people trained on those skills. Beyond the metaverse, China is also probably automated more than any other country in the world. How do you see that playing out in Europe? Are we keeping pace, or do we also have to go to the next level of automation in our factories?
So I think there are two sides of the same medal. The one side is, in Germany, we are still far ahead when you look at the robots per capita. So that's for sure, I would say. But if you now look at the installed base that's created every year, so every second robot shipped last year was shipped to China. And KUKA is profiting of this growth, of course. And there is a huge pressure behind this, let's say, kind of automation trend, because they realized already a few years ago that they will be in trouble in, let's say, 5 to 10 years because of the one-child policy. So they are already seeing this demographic change that also happens, by the way, in Germany and other countries in Europe. And their reaction was, okay, we need to push automation. And one key factor of automation is robotics. Because that's the most flexible way how to automate processes. You can use articulated robots, you can use mobile robots, drones, whatever kind of robot will help to automate and refill all the, let's say, workplaces that will be empty in the future because people will retire, so all our lives will end one day. So also, people will die, so they can't work forever. So you need to have another solution. I lately talked to the plant manager of a big plant of Siemens here in Germany, and he said they want to achieve an automation degree of 80%. And I asked, okay, why do you want to achieve 80%? He said, because if we want to keep the plant up and running also in 5 years, then we need to automate the processes, because otherwise we cannot fill all the open positions anymore. So they already see that they cannot fill all the open positions in 5 years, so they need to increase automation to keep production in Germany.
Okay.
And this relates also to my statement in the beginning. If we want to keep the same level of prosperity we have today, we need to find ways how we can keep production, manufacturing, also other industries in Germany and in Europe.
Thank you. And so now, moving beyond integrating robots more into the workforce, let's look at integrating robots into the daily lives of people and making sure that the technology is actually serving humankind. And here, I want to turn to Sami and talk about the incredible experiment that you're doing on the Technical University of Munich's campus. Can you tell us about it?
Yeah, more than happy to do so. So we at Technical University of Munich have the approach and take it very seriously that the technology we want to research and develop serves people. So I think it's safe to say that robotics is a transformative technology. One could argue that we are still in the middle and we're starting to leave the age of information, so the connectivity, the internet, the AI revolution, digitization. So we have this age of information in which we share information, we can use services, we can communicate basically globally, instantaneously. So now with the connection of robotics, AI and connectivity, we will now enter, and we are already entering, what I call the age of action. So I can basically connect to machines that are operating on the other side of the planet and do a diagnostic, for example, as a doctor. I can communicate, I can operate machines on other sides of the planet, maybe even beyond. So I think this transformation that is happening with the digital transformation is now into kind of a robotic transformation ending. So what we at TUM are now building is a campus in Garmisch-Partenkirchen, where the Olympics have been taking place in '36. It's a very well-known area in Germany that is beautiful. It's kind of in the middle of the mountains. It has a fantastic environment for living, but in particular, it kind of faces what we call the demographic change. So elderly people are really in need of great care, and we believe that robotics and AI can play a tremendous role in serving the elderly and serving the care sector in order to improve the service to the people. So what we are building in Garmisch-Partenkirchen is what we call integrated campus, which is basically directly behind what we call Zugspitzbahnhof. So it's kind of you come with the train to Garmisch-Partenkirchen, and we are right now starting this campus development, which will be finished in 2026. And the idea is that not only research, but also care facilities, care schools, and also elderly people who are kind of living there autonomously are in one campus. And we want together develop technologies, robotic technologies that can help in everyday environments, that can serve medical staff to do better medical services, obviously. And in particular, we want to basically research and develop and also translate technologies together with the elderly to enable them to live autonomously as much as possible and as long as possible. So to give them the freedom and the opportunity to have access to that technology in a way that they can live self-determined.
What I love about this idea is that the technology is not being developed in a vacuum, that you have not only the people working on the technology, but
Exactly.
you have, people who are experts on aging. You have elderly people themselves. You have the people who are going to be trained to be caregivers, all on the same campus so that they can learn from each other and make sure that this technology actually solves real problems and serves humanity. And so we only have a few seconds left. What's your call to action, Sami?
Well, I think for technologists, it's extremely important that we are shaping the world. We will define how the world will look like over the years to come. So I think it's extremely important that we enable technologists together with the stakeholders to be able to learn how to become a human-centered engineer. So how can we really make it the heart of our education and the way that we develop technology, that the human is always in the center of our developments. And I think this is the most urgent call for action in times of digitization, but in particular if we enter the age of action in order to go the right direction, in order to use ChatGPT, in order to use robots in a way that they serve us, humans.
And I hope that, people working on other types of technology will also learn from this systemic approach and this ecosystem approach.
Absolutely.
I want to thank you both. We're out of time, but let's have a nice round of applause for Sami and Quirin. Thank you both very much.